Valence bond theory, VBT. This theory was first introduced by Hitler and London and later developed by Pauling and others. This theory involved electronic configuration of the combining atoms, hybridization, overlapping of atomic orbitals, pairing of electrons, etc. Let us discuss the formation of hydrogen molecule. We know that hydrogen molecule is formed by combining two hydrogen atoms. Hydrogen molecule contain two hydrogen atoms sharing a pair of electrons. A single covalent bond, sharing of two electrons between hydrogen atom. Let us denote the hydrogen atom as A and B. We have two hydrogen atoms, hydrogen A, hydrogen B. We know hydrogen atom contain only one electron. Let us denote the electron present in hydrogen A as Ea, hydrogen B, electron B, Eb. And the nucleus of atom A, Na, nucleus of atom B, Nb. Two hydrogen atom with nucleus and electron. If the two hydrogen atoms are very far, large distance between the two hydrogen atoms, this is hydrogen atom A, this is hydrogen atom B, there is no interaction between them because they are very far from one another. There is no interaction between them, no attraction, no repulsion. But when they come closer, when the two hydrogen atoms approach one another, each hydrogen atom contains the nucleus and an electron. Second hydrogen atom, nucleus and its electron. When they come closer, they start interacting one another. There will be two types of interaction. First one, attraction, attractive interaction or attraction. Then the second one, repulsion. There will be repulsive interaction or repulsion between the two hydrogen atoms. How the attractions arise? Attractions are between, attractive forces arise between nucleus of an atom and its own electron, right? Nucleus of atom A with its electron Ea. Nucleus of atom B with its electron Eb. Means within the atom there will be attraction between nucleus and its own electron. When two hydrogen atoms come closer, there exists new set of attractive forces. New attractive interactions are set between atom A and B. How? Nucleus of one atom with the electron of other atom. The nucleus of this atom will attract this electron. Nucleus of atom B attract the electron of atom A. Means there will be attraction between nucleus of atom A with the electron of atom B. Similarly, nucleus of atom B attract electron of atom A. And there are repulsive interaction. The repulsions arise between nuclei of the two atoms, right? Nuclei, we know nucleus is positively charged. Like charges repel one another. So, nucleus of atom A repel with the nucleus of atom B. Similarly, electrons also in the two atoms will repel. Electron A, electron B repel one another. So, this attractive, when two hydrogen atoms come closer, attractive interaction try to keep them together. Repulsive forces try to keep them move apart. Experimentally, it has been found that attractive interactions are greater. Attractive interactions are greater than repulsive interaction. So, what happens? Two hydrogen atoms will come closer and closer. When two hydrogen atoms come closer, the oneness atomic orbitals of two hydrogen atoms come closer and closer. And the energy of the hydrogen atom decreases. When two hydrogen atoms come closer, attraction becomes greater than repulsion. That means they are getting stability. Since there are strong attraction between there is strong attraction between A and B, their potential energy decreases. And they reach at equilibrium. At a particular stage, what happens? This attractive interaction balances with the repulsive interaction. These two becomes equal. And the system attain minimum energy. That stage is called equilibrium. At that stage, we say the system attained equilibrium. At equilibrium, what happens? Attractive interactions becomes equal to repulsive interaction. And two hydrogen atom attain minimum energy state. At that stage, we say the two hydrogen atoms are chemically bonded. Sharing of electron takes place. This can be explained. We know when two hydrogen atoms come closer mean oneness atomic orbital which are half filled, right? Let this be the oneness atomic orbital of hydrogen atom A. This be the oneness atomic orbital of hydrogen atom B. When they come closer, this oneness atomic orbitals with one electron of first hydrogen atom partially merge with oneness atomic orbital of the other atom. In this partial merging, what happens? These electrons undergo pairing. The single electron present in the oneness atomic orbitals undergo pairing. This partial merging of or oneness atomic orbital of hydrogen atom partially interpenetrate one another. This partial merging or partial interpenetration of atomic orbitals is called overlapping. This is called overlapping. During the overlapping, pairing of electron takes place. Oneness atomic orbitals, the electrons undergo pairing. At this stage, we say the two hydrogen atoms are covalently bonded. They share a pair of electron. They share a pair of electron. Hydrogen A, hydrogen B share two electrons between them. Or we can say hydrogen atom are covalently bonded. H2 molecule is formed. When this overlapping happens, they lose certain amount of energy. I told they attain a minimum energy state, losing their energy. That amount of energy lost when an H2 molecule is formed is called bond enthalpy. When two hydrogen atoms combine to form an H2 molecule, they release certain amount of energy which is called bond enthalpy. This bond enthalpy of H2 molecule is 435.8 kilojoule per mole. Means when H2 this much amount of energy is released. If you want to break H2 molecule into hydrogen atom, this much amount of energy should be supplied. And at this stage, the internuclear distance between the atomic orbitals, between the two hydrogen atom is called bond length. And this bond length in H2 molecule is 74 picometer. Bond length, the internuclear distance in the bonded state between the two hydrogen atom is called bond length, which is equal to 74 picometer. The bond length of H2 molecule. If you plot a graph with energy against internuclear distance, energy of the hydrogen atom along the y-axis, internuclear distance in picometer along the x-axis. Initially, the internuclear distance is very large, means the two hydrogen atoms are very far. Large distance. So, internuclear distance is very large. This represents the energy zero state. Initially, when the two hydrogen atoms A and hydrogen B are far apart, there is no interaction between them, their energy values are higher. They have got higher energy. When they come closer, when the two hydrogen atoms approach one another, internuclear distance decreases and decreases. When the atomic orbital, oneness atomic orbitals of two hydrogen atom partially merge with the oneness atomic orbital of the other hydrogen atom. The oneness atomic orbitals partially merge and pairing of electron takes place. What happens? They reaches a minimum energy state. At this stage, what happens? H molecule is formed. H2 molecule is formed. Hydrogen covalent bond is formed. A minimum energy state, at this stage, H2 molecule is formed. On further decrease in distance, what happens? The molecule becomes unstable and its energy goes on increasing. And this minimum energy state, this amount of energy, this hydrogen molecule released when hydrogen molecule is formed, this amount of energy is called bond enthalpy. This amount of energy is equal to 435.8 kilojoule per mole. And the internuclear distance between the two hydrogen atom in H2 molecule is called bond length, which is equal to 74 picometer. When two hydrogen atoms, when oneness atomic orbitals overlap one another, H2 molecule is formed. And the amount of energy released during the formation of H2 is called bond enthalpy. And the internuclear distance between the two hydrogen atom in this overlapping condition is called bond length. That is, accordance with the valence bond theory. According to valence bond theory, a covalent bond is formed due to overlapping of atomic orbitals. Overlapping of atomic orbitals present in the valence shell of combining atom result in sharing of electron. So hydrogen atom, hydrogen covalent bond is formed due to overlapping of oneness atomic orbital, half-filled oneness atomic orbitals present in two hydrogen atom. And the strength of a bond depends on, strength of the covalent bond depends on extent of overlapping or degree of overlapping. Greater the degree of overlapping, stronger the covalent bond. When atomic orbitals present in the valence shell of combining atom undergo partial merging or partial interpenetration, a covalent bond is formed. That partial merging of atomic orbital is called overlapping. Greater the extent of overlapping, greater the strength of the covalent bond. During the overlapping, pairing of electron takes place between the atom or sharing takes place. Covalent bond is formed.